YouTube classes by Ganesh Habba. So today's topic which we are going to discuss is some of the numerical problems of electricity chapter number 12, that is numerical problems part 1. The first problem is, what is the work done when 2 coulombs of electric charge move across potential difference of 15 volts? So what are the given values? Given values are, when 2 coulombs of charge, that is charge q is equal to 2 coulombs, and charge moves across a potential difference of 15 volt, that is v is equal to 15 volt. They are asking work done is equal to how much, that is work done is equal to how much. We know that we have from the formula of potential difference, that is potential difference V is equal to work done divided by charge, work done per unit charge. So what we require? We require this, rearrange this equation as W is equal to V into Q, so that we end up getting 15 into 2, which is equal to 30. That is work done is as, so unit of work done is 30 joules. So 30 joules is the answer. The next question which is asked is, 400 watt rated refrigerator is used for 8 hours per day. That means the given values we need to write. So given values are, the watt, that is power, is equal to 400. It is given 400 watts of refrigerator is used for how many hours? That is time is given, time is equal to 8 hours it is used, but they are asking the cost and energy for 30 days. So 8 into 30, like that, per day it is 8 hours into 30 days, so which is equal to 240 hours of time it is used. Then cost for 1 unit, or 1 unit is nothing but 1 kWh, which is equal to 3 rupees. They are given it. Then we need to calculate energy is equal to how much, and cost is equal to how much, total cost. It is nothing but the total cost for 30 days will be equal to how much, that we need to calculate. How to calculate that? The formula for energy is equal to, that is P into T, which is equal to, P is 400, 400 into T is, it is 240 hours, 240 hours. So it will be, it is watt, 400 watt and 240 hours. So answer will be in watt hour. So it is 96,000 watt hours we will get. So WH. But here there are 3 zeros. 3 zeros is nothing but 1000, 96,000. So it can also be written as, instead of writing 96,000 watt hours, I can write 96 kilowatt hour. So that is kilowatt hour. Next, the energy. The formula is that I can write it as E is equal to, in other words, I can also write it as 96 units of energy is consumed. So now the cost for 1 unit is given. How much? It is 3 rupees. Then what is the cost for total cost? If total cost for 96 units, which is equal to how much? That is equal to, I can write 96 into 3, which is nothing but 3 6 8 9 6 9 3 and 288. Yeah, so answer is 288 rupees. That is rupees 288 is the answer for this particular question. Third question is, three resistors of resistance 30, 20 and 60 ohm. So given values are, R1 is R1 is equal to 30 ohm, R2 is equal to 20 ohm, and R3 is equal to 60 ohm. What they are done? They are connected in parallel circuit to a 12 volt battery. That means potential difference is given. That is 12 volt. Calculate the total resistance of the circuit and the electric current in the circuit. So the question asked is they are connected in parallel. So the given situation is like this. So this is one more resistor and this is one more resistor. They are all connected in parallel to which battery? A battery of 12 volt. So this is R1, this is R2, and this is R3. The values are 30, 20, and 6. Sorry, not 6, it is 60. Okay. Next, we need to calculate the total resistance. So what is the formula for the effective resistance in the parallel combination? That is 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3, which is equal to 1 by 30 plus 1 by 20 plus 1 by R3 is 60. So which can be written as, so make it 60 everywhere. So it is 2 by 60 plus 3 by 60. It is 3 by 60, and this I can write it as 1 by 60. So 60 is common. So left hand side is 1 by Rp, or 1 by Rp is equal to plus 3 plus 1, that is 6 by 60, which is equal to 6 1s are 6 10s, that is 1 by 10, which is, that is 1 by 10. Now this implies Rp is equal to, how to write Rp? Rp is equal to 1 by 1 by 10, that is value is 10 ohms. So 10 ohms is equal to the calculate the total resistance. Total resistance is equal to 10 ohms. I will write it properly. It is 10. 10 ohms is the total resistance, and total resistance of the circuit and the electric current in the circuit also we need to find out. So we know. So now Rp is equal to 10 ohms. So resistance is net resistance of the combination, that is net resistance of the total combination is, it is 10 ohms. So it is 10 ohm. Now we know that V equal to 12 volt, then I is equal to how much? So we have from the Ohm's law, V is equal to IR. So I is equal to V by R, which is equal to V is 12 divided by R is 10, which is equal to 1.2 ampere is the current flowing in the circuit. The next question is, an electric lamp whose resistance is 40 ohms and conductor of 8 ohm resistance are connected in series to a 12 volt battery in the electric circuit. Calculate the total resistance of the circuit and the current flowing through the circuit. We need to find out. Now they have given, that is we have to write the given values. Even if they have given it as the lamp, we need to write it as it has some resistance. That is why we have to take it as R1 is equal to 40 ohms, sorry. So R2 is equal to 8 ohms, and they are connected in series. So to a 12 volt battery. So V is equal to 12 volt. How they are connected? Like this. This is one resistor. This is a lamp. This is one more resistor. That is, this is 40 ohm. This is 8 ohm. Even if they have given it as a lamp and they have given some resistance, we have to consider it as a resistance only. So next is about the battery to be connected of how much? 12 volt battery. So they are asking what is the total resistance of the circuit. So in the case of series combination, the effective resistance Rs is equal to R1 plus R2, which is equal to R1 is 40, R2 is 8, which is equal to 48 ohms is the effective resistance of this particular combination, that is 48 ohm. Now they have asked us to calculate the current. So current I so equal to V by R. From where does we obtain this? From Ohm's law. V is equal to IR. From this I can write I equal to V by R. But V is given, R we have already calculated, it is nothing but RS. So V is nothing but 12 divided by R is nothing but RS, that is 48. So 12 ones are 12 fours are, which is equal to 1 by 4, which is equal to 0.25 amps. 0.25 amps of current is flowing. So asked questions are RS net resistance in the total resistance in the circuit and the total current. Total current equal to 0.25 amps. These are the answers. Question number 5 is an electric bulb with a resistance of 50 ohm is connected to a 10-volt battery in an electric circuit. Calculate the electric current flowing through the circuit, flowing through the electric bulb and electric power of the bulb they are asking. So given values are, what are the given values? An electric bulb with a resistance of, that is R is equal to 50 ohms is connected to a potential difference of 10-volt battery in an electric circuit. Calculate the electric current flowing through the circuit. We need to find out current I. It is just simple. It is from Ohm's law. V is equal to IR. So I is equal to V by R. That's it. V is given, that is 50, and V is given, that is how much? V is 10. 10 divided by R is 50, which is equal to 1 by 5, which is equal to 0.2 amps. 0.2 amps. That is the current flowing. It is the electric current flowing through the circuit. And electric power is also asked. How to find out the power? Power P is equal to V into I, which is equal to V is given and I we have already calculated. So V is equal to 10 into I is equal to 0.2, which is equal to 10 into 0.2 is 2. And what is the unit of power? It is nothing but watt. It is a bulb is of 2 watt of power and current is equal to 0.2 amperes. So these are the answers for the given question. The next question is an electric heater of resistance 8 ohm draws 15 amps of current for 2 hours. Draws 15 amps of current for 2 hours. Calculate the heat developed in the resistor. So we have to write the given values. Which are the given values? Given values are heater of resistance R is equal to 8 ohms, it is given, draws a current of I, that is current is given I is equal to 15 amps. For how much time? Time is given, that is for 2 hours. Calculate the heat developed in the resistor. So in order to find out the heat developed, we need to convert this particular time to into what? 2 hours into second, that is 2 into 60 into 60. It is equal to 7,200. So the formula for the heat developed H is equal to, what is the formula from Joul's law of heating? That is I square RT. It is a formula for heat developed. So I is given, I is equal to how much? 15 into 15, that is 15 square, into r is equal to 8, into t is nothing but 7200. The answer of this particular question will be, so the answer is, I have calculated it, 1296, 4 zeros. Yeah, so I can write 1, 2, 3, 4, 5, 6. So 12 point, which is equal to 12.96 into 10 to the power 6 joules is the answer for this particular question. Next question is, compare the power used in each of the following. First case, we shall discuss one by one. We need to find out the power in A as well as power in B. First case A is potential difference V equal to 6 volt, and the resistors R1 equal to 1 ohm and R2 equal to 2 ohm, both are connected in series. Then what is our aim? In order to find out P, power, we need to find out what is the formula for power if we have V and R only. So let us see. The actual formula for power is V into I, but I is not given. We can find out I, then we can substitute the value, but instead there is a formula for I, that is V by R. So in place of this I, we substitute the value of V by R. So we end up getting the formula for power is V square by R. But R we actually don't have, but we can calculate, both are connected in series. So in series, RS, series combination of resistors, that is RS is equal to R1 plus R2, effective resistance in series combination, that is 1 plus 2, which is equal to 3. So R we got R now. So substitute this here. V is already given. So power is equal to V square by R. This formula we are using. This formula. So V square is 6 into 6 divided by R. R is RS, which is nothing but 3. 3 ones are 3 twos are, which is equal to 12 watt for the first one. For A, that is 12 watt. 12 watt. Now for B, let us see what is the power for B. So given a 4 volt battery, 4 volt battery ಅಂತ ಕೊಟ್ಟಿದ್ದಾರೆ. So voltage V equal to 4 volt and in parallel with 12 and 2 ohm resistors. So there are two resistors connected in parallel, that is R1 is equal to 12 and R2 is equal to 2, both are connected in parallel. So effective resistance in parallel, that is 1 by Rp is equal to 1 by R1 plus 1 by R2, which is equal to 1 by R1, that is 1 by 12 plus 1 by 2. How to write this is nothing but it is 1 by 12 can be written as, as it is 1 by 12 plus 1 by 2 can be written as 6 by 12. So that I will get 7 by 12 as 1 by Rp. So therefore Rp equal to how much? Rp is equal to 12 by 7. That is the value of Rp, effective resistance. Now substitute that value here. V square by R. That we need to calculate. What is the power? Power P is equal to V square by R. How to obtain that V? V is nothing but, V is how much? That is 4. So 4 into 4 divided by R. R is nothing but 12 by 7. So when it comes to the numerator, I can write 4 into 4 16 divided by, or I can write into 7 by 12. That is 4 3s are 4 4s are. So which is equal to Ilna clip path into 28 divided by 3, which is equal to 28 by 3 is 3 ones are 3 nines are 3 nines are means 27. So nines are, that is 27.3. So 9.3. What is the unit? That is the power. So watt. So where will be the power will be maximum? So in A, the power consumed in A case, first case, will be greater when compared to the power consumed in B case. Power consumed in A case it is 12 watt. Power consumed in B case it is 9.3 watt. That is the answer for that particular question. Problem number 8 is a bulb is marked 220 volt and 40 watt. What we need to calculate? The current flowing through the bulb and its resistance. So given values are V is equal to 220 volt, power P is equal to 40 watt. We need to calculate the current I is equal to how much and resistance of bulb is equal to how much, that we need to calculate. How to calculate? So we have power P is equal to V into I, that is the formula for power. But we have P and V, but we don't have I, we require it. I is equal to power divided by V, which is equal to power is, it is given how much, that is 40 divided by V, it is 220, that is 0 0 cancel, 4 ones are 4, how many are 4 twos are, it is 4 11s are. I hope it is right. So 2 twos are 2 11s are. So 2 by 11 amperes is the amps. So amperes. So current flowing equal to 2 by 11 amps. And current flowing is over. Next, the resistance of the bulb we need to calculate. R is equal to how much? That is V is equal to IR. V is equal to IR. So R is equal to V by I, which is equal to V is 220 divided by I is 2 by 11. So when I take it to the numerator, it is 220 into 11 by 2. 2 ones are 2, 1 tens are 110 into 11, which is equal to 121 0. That much of ohms, 1210 ohms of resistance. So required answers are current flowing is 2 by 11 and the resistance of the bulb is 1210 ohms is the answer. Thank you.